Our discussion is on dynamics. So first of all, in very beginning point of dynamics discussion, first we will talk about the inertia of a body. Earlier also, while discussing the state of motion, I discussed something about inertia. So can you tell me what is inertia of a body? It is the tendency of a body which resists any kind of change in the motion of the body, right? The body, the inertia of a body, we can say it is the tendency which it can maintain either in a state of rest or state of motion with uniform velocity. That means there can be two different state of inertia. There can be two different state of inertia. One is called static inertia, another one is called kinetic inertia. Okay. So inertia of a body is the tendency which it can maintain either in a state of rest or the state of motion with uniform velocity. That is during the state of inertia, it does not changes its motion, okay. Whatever the state of motion, either it is in a state of rest or if it is moving in a moving with uniform velocity, then both these things will be maintained by it. That means, in other words, in a very simple language, we can say the inertia of a body is the tendency by which it maintains either the zero velocity state or constant velocity motion. Okay. So in a very simple state, we can directly comment on the type of motion what a particle can acquire as a result of inertia. So we can write down, due to inertia a body can be found in a state of rest, or motion with uniform velocity. Okay. So inertia means there can be two possibility of a particle, either a body will be found in a state of rest or a motion with uniform velocity, that means one state is called static inertia, one state is called static inertia. The static inertia is the state of rest. Okay, it is the state of rest. Means no motion, that is zero velocity. Static inertia means zero velocity state. Are you getting it? Static inertia means state of rest, or in other words, if it is not moving at all, then we can also comment about its velocity as if it is zero. So zero velocity state can be said to be the state of rest or the static inertial state. And second is the kinetic inertia. kinetic inertia, which is also called inertia due to motion. Okay, so we can write kinetic inertia. So kinetic inertia means it is the state of motion, it is the state of motion with constant, with uniform velocity. When we use the word uniform velocity, means where velocity remains constant, where velocity remains constant. If we say that velocity remains constant, so under which kind of motion, velocity being vector quantity, if that is said to remain constant, okay, the meaning of the word velocity remains constant means a body can only be said to be moving under constant velocity when it covers equal distance in equal time, and that too in a straight line. So that's why we can explain this uniform velocity motion means uniform velocity motion means more specifically means motion in a straight line, motion in a straight line with constant velocity magnitude, with constant velocity magnitude. Are you getting it? Whenever we can say a particle is moving in a straight line with constant magnitude, then only we can say the particle is moving with the uniform velocity. Any other particle moving along any path other than the straight line can never be said to be moving with uniform velocity, because whenever particle will move along any path other than the straight line, that means direction of motion will definitely change. Whenever a particle will move along any path other than straight line, that means the direction of motion will change, and hence particle moving along any other path other than straight line can't be said to be motion with uniform velocity. Are you getting me? Are you all getting me? So therefore, that means what I want to say, that if a particle, suppose if I draw a straight line, if I draw this is a straight line, at different instant I can see a particle moving with a velocity v meter per second at various instant during its motion. If I draw it, and if I will see that its velocity remains same in magnitude and same in direction, right? So that means it is definitely moving with uniform velocity. This is the meaning of the motion of a particle continuing with uniform velocity. But for other example, for example, a particle is moving in a path like this. Okay, particle is moving along a path like this. Then what will happen? It may possible that particle speed magnitude, that is the what we write down the magnitude of the velocity, it may possible that it is constant throughout the motion. Okay, it is constant in magnitude wise, you can say here in this case it is definitely constant in magnitude, but you can say the direction what I got it over here at the first point, it is different in second, in third point it is further different. Are you getting me or not? Direction of motion is continuously changing, right? So this is the path 1, is the path 1, this is the path 2. So in path 1 we can see particle moving without changing direction and with a constant magnitude, particle moving along the straight line with same magnitude, means it is a uniform velocity motion. This is a uniform velocity motion. This is a uniform velocity motion, right? The first one, path 1. But the second one, this one I can write down, it is uniform speed motion. This is uniform speed motion. Why we can't it as a uniform velocity? The reason behind, direction is changing. In this part we can say magnitude is constant, but direction is changing. In the second one, how we can understand the direction is changing? That we can understand by the direction of the arrow representing the velocity vector, right? Are you getting me? What is the meaning of uniform velocity and what is the meaning of uniform speed? Uniform speed does only matches up with the word magnitude. Okay, uniform speed means magnitude is constant. Uniform velocity means magnitude is constant and direction same. That means constant magnitude and same direction. Constant magnitude and same direction, that makes its uniform velocity, right? And constant magnitude but different direction is making it as a uniform speed. Are you getting me or not? So kinetic inertia motion means it has to be a motion under uniform velocity. So therefore in overall meaning, overall we can say kinetic inertia can only be justified by the motion along straight line. Kinetic inertia can only be justified by the motion along straight line with constant magnitude, with constant velocity. Is it clear? So are you getting it? Which type of motion can be representing the kinetic's inertial state? Static inertia is simply about the state of rest, but kinetic inertia is definitely about the state of motion. But just observing a particle moving along a path, how can we comment on about its status of inertia? If we can see a particle moving along any path other than straight line, then we can comment on that it is not at all a motion under kinetic inertia. But whenever a particle will be observed to be moving along the straight line with the constant velocity, then that can only be the reflection of maintaining kinetic inertia. Okay, so there cannot be any other path motion other than the straight line can justify the kinetic inertial state of motion. So ultimately, whenever we use the word inertia, either it is the static inertia or kinetic inertia, means we are talking about the state when there is no force. Inertial state means, we can make another point of learning, inertial state means situation with no force acting on the mass. Is that clear? Whenever we talk about the static inertial state or kinetic inertial state, means we are talking about such state where either body is at rest, or if it is in motion, then it will continue motion with the constant velocity. In that case, force acting on the body must be 0. So that means whenever we are in inertial state, there is no force acting on the mass. So that's why it is important to know that inertial state means situation with no force acting on the mass, right? Whenever some unbalancing force will act, whenever some unbalancing, have you written the last lines? Whenever unbalancing force will act, that will definitely produce the resultant motion, that is the accelerated motion. But so long as there is no force acting on a body, that means we can clearly say that yes, the body is maintaining its state of inertia. Now one question, that means if state of inertia that happens to be the situation without force acting on it, right? Inertia is the state of the body when no force acting on it. Then question arises, can we change our inertial state by ourselves only? Can we change our state of inertia by our own effort? How will you answer it? Can a body change its own state of inertia? Yes or no? We cannot change our inertia, because see what happens if you start running. If you think of starting a run from a state of rest, you take action, okay, you take a position like a sprinter, and then you start running. So do you think that it is you who is making yourself comfortable to start the run? No. Answer is no, because you can do that as because you are trying that on a rough surface. You are trying that on rough surface, so here friction force takes that responsibility to give a better grip to your feet, okay, and then you create an extra jerk on the ground in the backward direction, and then your muscular energy is taken into the role to generate the motion, right?